So solving radical equations. Solving radical equations. First example is 12 equals 4 square root of 2x plus 1. When you do these kinds of problems, you want to, it's one of these weird things, it's like almost always get the square root by itself. So in this case, yes, you want to get the square root by itself. So how can we do that? Divide by 4. We get 3 equals square root of 2x plus 1. How do I undo what is the opposite of taking the square root of something? Casey? Square it. So we're just going to square both sides. What happens on the left side? What do we get? 9. When I square a square root, what happens? You just get what's under. It goes away. So 2x plus 1. Then it's a pretty simple algebra problem, right? First I subtract 1 from both sides, and then I divide by 2. Oh, Kevin, get worse! It didn't make sense. Yep, that's how it goes. Okay, example number 2. Give you a second. Looks like a couple people need a second to finish writing it down. Example number 2. No. So we are going to do the cube root this time of 9x plus 1 equals the cube root of 11 plus 8x. So to undo a cube root, what am I going to do, Antonio? Just cube it. And I just, in this case, instead of squaring the square root, cube the cube root, you end up with what's underneath, yet again. And, no problem. So then again, it's, you know, a little more difficult algebra problem, but not that much more. So we're going to subtract 8x and subtract 11 from both sides. Take your headphones out. I see you dancing. No, thank you.
Mr. Evans, you should have a March Madness polling class like exercise on it.
That's great. It's fast. I don't think I'm allowed to do that.
Well, you call it something else.
When I have just x, I want to get the x on one side and the number on the other. When I have x squared, that's when I want to get everything on one side. And we'll do one like that coming up next. Okay, yeah, Mark. Well, after I add the x's on this side, right? You're speaking way too quiet for me to hear you. Why I get -1? Well, what's positive, right? So I'm just doing the opposite. Okay? Yep. Yeah, you could do it multiple ways. Your method just costs you one more step. That's all. No big deal. All right, example 3. Ramps it up just a little bit. And then example 4 brings it home. I still have my lovely cup. I have to do this one and this one. Actually, I'm going to switch that from Casey, come get your little note. I have no idea. I haven't looked at it.
They found the Coke in the locker.
Hey, you two boy. I'm going to play that back for your mom.
You better laugh, honestly.
You hope. Okay, so I have to get the square root by itself, so I have to do what, George?
Put the 2 on the other side and then you can, square both sides.
Okay, focus. So I get square root, x minus 1 equals negative x plus 2. So I have to undo the square root by squaring. So the cardinal mistake is to take that 2 and distribute it. Don't do that. You get it wrong. Okay? When I square this side, what it means is it means FOIL, exactly. Who's the whistler? Like, really? Can you shut up? It's okay. Repeated whistling can deserve a little something. Alright, so I got x minus 1 on the left, and then I have to FOIL that. It's a little weird foiling with the negative x, right? But yeah, that's okay. Go for it. So I think, why is it minus x squared? Well, it should be plus x squared. Thank you, Boo. So I think it's always easier, Casey, be quiet. I think it's always easier to keep the x squared positive. So I'm going to get rid of this stuff on the left, move it over to the right by subtracting x and adding 1 to both sides. So we get 0 equals x squared minus 5x plus 5. And if you want to know if it factors or not, it doesn't. But if you have trouble figuring that out, you can always do the cross, a times c on top, b on the bottom, so I'd have 5 on top and negative 5 on the bottom. And nothing multiplies to positive 5 and adds to negative 5. So you're lucky enough to do the quadratic formula.
Look at my middle name.
Okay, so I'll plug it in real quick here. So, we get 25 minus 20 underneath the square root. So we get 5 halves plus or minus square root of 5 over 2. So here's the problem with this kind of problem. Sometimes you get extraneous answers. Sometimes both answers work. Sometimes one answer works. Sometimes none of the answers work. So it's really fun when you go through a whole problem like this, and the answer is, what's the most irritating answer you can get? No solution. You do all the work and you get no solution and you're like, oh my god. But it happens. Oh well. So I want to plug this in my calculator to see what 5 halves plus square root of 5 root 2 is, and then see what 5 halves minus square root of 5 root 2 square root of 5 over 2 is. So I'm going to do that. So it was 5 divided by 2 plus so see, some of your calculators look like this, and you have to hit the right arrow to get outside of the square root, and then you can divide it by 2. Other of your calculators will look like this. So you'll have the 5 divided by 2, and then plus, and then they give you the beginning of that parenthesis. You have to close that parenthesis, otherwise you will get the wrong answer, because it'll do the square root of 5 halves instead of the square root of 5 divided by 2. Two totally different things. So what I recommend is you bust out your calculator and make sure you get the same answer I get, because I can't tell you how many people put this in incorrectly into their calculator. So if I do that, I get 3.6, and then remember the handy feature on your calculator, you just hit second, enter, puts the exact same thing back in, and then you can just arrow over and switch the plus to a minus, and hit enter. I hit second, enter, to put the thing back in. So you should get 3.6 and 1.38. So try that, make sure you can do it, I'll give you a sec. So you want to figure out which one's extraneous. What? Okay. To figure out which one's extraneous, we're going to put the original problem into the y equals. And that's the easiest way to figure out which answer is extraneous, as well as to double check your answer in the first place. Okay? So if we go back, you guys need a minute to put that in your calculator? Anybody need a minute? We're going to do the y equals now. Go back to the problem, look at the original. So I'm going to put, at this level, I'm going to put it in, where I have just square root on one side, and all the rest of the stuff on the other side. So I'm going to put square root of x minus 1 on one side, in y1 rather, and then negative x plus 2 into y2. So square root of square root of x minus 1 in there, and then it was negative x plus 2. Because we want to figure out which answer is extraneous. Will it what? No, it'll only give you one answer on the calculator. Okay, so plug that into your graphing calculator. It's important to know how to do this because you can check your answer as well. Just a graph, yep. How do we figure out where those cross? Second trait, number 5 is intersect. Enter 3 times. 1 sec. Nah, it doesn't matter. It's never not worked for me, but this is okay. There's only 2 intersections though. I mean 1 intersection. So it's just 0, because I guess maybe because I'm off the curve. Alright. So maybe you have to see the cursor. Second curve there. Enter once more. 1.38. So the 1.38 answer is our one and only answer. So when I go back to that, which one was that? Was that the plus or minus answer? Okay. So 5 halves minus square root of 5 over 2 equals the 1.38. That is our answer. So if you get to right here on the test on Monday, you get 4 out of 5 points. If you give me both decimal equivalents, you get 4.5 out of 5. If you tell me which of the two decimal equivalents works, then you get to 5 out of 5. Could get lucky. Second trace intersect, not too hard though. Okay.
How did you, from the graph, into the graph?
Yep. Go ahead, ask your question, Antonio, what's your question on the graph first?
No, I figured I was going
Okay. So, what's your question? Because when I put it in the graphing calculator, when I added them, I got the bigger number. When I subtracted them, I got the smaller number. And when I had them intersect on here, I got the answer subtracted as where they intersect. So that's the answer. Where they intersect. Yeah. Eli, go back to what? Go back to what? Okay. You could plug it in. That's another way to do it. But if you do the second trace intersect on the calculator, then it's also double check on your putting it into the quadratic formula. Right? So that's why it's better to use the graphing calculator. You could plug it in totally. That's another way.
You could just plug it into that without doing all that stuff.
Oh, you could, but then I give you 1 out of 5 points. Yep. Mark? Where it would intersect twice? No. Because when you have a square root graph, it will always look like this. Start on the x-axis and go off either way, but the other graph's going to be a line, and you can't draw a line through this curved graph and have it. I don't think you can have it this way. There's probably an exception where you can, but I don't think you can. So from right here, you got to hit graph first, second trace, go down to number 5. Hit enter. You got to make sure you can see the cursor. So did it not work on yours, or you just need to know how to do it? Okay. Make sure you can see the cursor. So right arrow, you can watch the X values to know where the cursor is, right? So it says 2.55, so I can see the cursor, and then enter 3 times. Literally never happened to me in 7 years of teaching where that didn't work. Of elementary teaching.
Wow.
16 overall. What's that? Okay. Eli, what's your question? Say that one more time. You just have, what's that, plus 2 to make it back to 2? And is it x minus 1? So look over here. So So I'm moving the number. I Eli, what was your question? Where did you get the negative x? I got the negative x plus 2. Okay, mark down. From right here, 1.38. Right, because I have to put in just the square root part into y1, and then everything on the other side into the y2. That's why. Okay, last ugly example. You'll see the example looks kind of harmless at first, and then once you start manipulating the equation, if I start, you guys start groaning in the middle of the example. And go, "Oh." If you know it's going to be tough.
We think we're like 2 steps away, and then
Yeah, and then it goes on to like 6 more, and you, yeah. I've tried it both ways. This way's better. So bad, huh? Okay, so let's do. One doesn't work right away. Okay, write that down for your class. Now on to a little side conversation. So, first step, square both sides. And then, on this side, no problem, we get 3x plus 4. On this side, more of a problem because we get square root of x minus 2 times square root of x minus 2. Yep.
Why doesn't that, if my square is not the absolute square root, so why doesn't it?
It's different when, because this isn't under a square root, this minus 2 is not under a square root, so it messes everything up because of it. No headphones. No headphones.
So what's the square root of the square? I'm still looking at the square root. But then it's square root times.
What's your question, Rachel? It would be x plus 4 if you're doing it incorrectly in that manner. But this is why. Watch what happens when we FOIL. Square root of x times square root of x is x, or the square root of x squared, which is x. Okay? So square root of x times square root of x is x. Outside we will get negative 2 square root of x. Inside we will get negative 2 square root of x. And then the last, we would get positive 4. So if you just distribute the 2, you miss the middle 2 terms. So it's massively incorrect. And I aggressively take points off because it makes me angry. Because I have to emphasize the crap out of that for all of your junior year. I guarantee I will take more points off because it makes me mad. So we get 3x plus 4. At the beginning, that's the easy part. How did I get x? Because square root of x times square root of x equals square root of x squared. Square root of x squared is x. Okay? That's why it works. It's easier to see if you do square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. So when you multiply what's underneath the square root together, we just, or if you do square root of the same number or same letter times square root of the same number or letter, we just end up with what's underneath right here. Okay? So, if I combine the middle here, I get negative 4 square root of x. I want to get the square root part by itself. So I have to subtract x and 4 from the right side. So I get 2x equals negative 4 square root of x. So I can just square this part, right? It's not negative 4 plus square root of x. It's negative 4 times square root of x. So I'm just going to go ahead and square at that point.
Why would you not divide negative 4?
You could, it just makes it uglier,
Okay.
because you have a fraction on this side, and I'd rather square without a fraction. Easier. So negative 4 times negative 4 is 16. Square root of x times square root of x is x. So 2x squared is 4x squared. So if you want, right here is multiple options. I could subtract 16x over. I could just divide both sides by 4. Right? So if I divide both sides by 4, then I get x squared equals 4x. Then I could subtract 4x over. No. Since it's a positive 4x. So I get x squared minus 4x equals 0. And then I just factor that left side to what?
Wait, no, what about?
Oh,
Nope.
I don't.
What do you have, Bruce?
That was 4x squared equals 16.
You divided by 4x?
I divided 16 by 4 and 6 squared by x, and that's x equals 4.
So you divided like that?
Could you do that?
Sure. Then if we did that, we would get x equals 4. That's fine. That's what, isn't that what you did?
Did you do something different?
Okay. No, that's fine.
Can you do that?
I mean, we can do it, sure.
Will you take part off?
No, that's fine if you want to do that.
No.
That's what you asked? I had like 4 people talking at once, sorry. Do it that way, that way it's easier. Who gets the best? Alright, what's your... Oh, because we have to square both the... So the question was, why is this 4x squared? Because we have to square both the 2 and the x. Right? Back in freshman year, if you do anyways, I have them learn to put little 1s on there to remember to multiply the exponents. 2 times 1 is 2, so it's 2 squared and x squared. And then it helps them fix it. So we want to plug that 4 back in to see if it works. That's the step that you're going to forget on a test. So plug it back in, see if it works. We're plugging 4 back in. I plug in 4 here, I get 12 plus 4, which is 16. That equals 4. If I plug in 4 here, I get 2 minus 2, which is 0. So what's the answer after all that work? The most annoying one. All that work to get no solution.
So we, because like x plus 4, or x equals 4,
Yep.
All the back, plug it back in?
Huh?
Plug it back in?
You have to plug it back in to get full credit. You have to, I mean, if you get x equals 4, you get 4 out of 5 points. If you rate no solution, you get 5 out of 5. Which is annoying, yeah? But that's the way it goes. Alright, so that's that.